Hello, scholars, and welcome to our lesson on finding the hypotenuse using the Pythagorean theorem. This is in angles and triangle theorems, and the goal is that you will be able to find the hypotenuse of a triangle using the Pythagorean theorem. The reason we're working so much with triangles is because, as has been said previously, triangles, both mathematically and physically, are literally one of our strongest shapes. Non-exaggeration, it genuinely is why it's used for so much in our building and general just construction design work. It's one of our strongest shapes. Being more comfortable in working with it and solving problems with triangles just makes us better at interacting with our own world. Let's begin. First, with a warm-up pop-up. So, with your notes, you have a foldable. Your first task is cut out the given foldable. So you have just this part exposed. From here, you want to find a way to cut out the squares of both legs and create a square on the hypotenuse side. So you have these squares here, these squares here. You need to find a way to cut out and reorganize them so you make a square for your hypotenuse. I'm really excited to see how you go about doing that because there's actually a lot of ways you could. So I'm curious to see how you ended up making your new square using these squares. With that, don't forget, cut out one, cut out the other, and again, cut them in a way that you can make a new square for your hypotenuse. Now you want a chance to do that. What you're doing is what a mathematician did a long time ago in discovering what's called the Pythagorean theorem. When I say a mathematician, I mean Pythagoras. It's why it's called the Pythagorean theorem. A mathematical philosopher named Pythagoras discovered this, kind of doing it in a similar way to what you just did for the warm-up. The idea is if we take the sides of the legs of the triangle and square the measurements, in other words, literally make them into squares, we can combine the squares of both legs to discover what a mathematician, Pythagoras, discovered many, many years ago. If you take one leg square and the other, much like you probably did in your warm-up, you can make the square of the hypotenuse. And this is a pattern that works for any right triangle. So giving this knowledge, Pythagoras made a theorem to quickly find missing pieces of a triangle. And it is called the Pythagorean theorem. If a triangle is a right triangle, like this one, then we know that if you square one of your legs, if you combine it with the square of the other leg, you will get the square of the hypotenuse. Or, as it's most commonly called, and you hear this all the time when people want to just throw out a random math formula, they'll say a squared plus b squared equals c squared. These mean the same thing. Leg squared plus the other leg squared, and squared as in to the power of 2 equals the hypotenuse, or c squared. Let's use that in a problem, actually. 2 problems. Your first step is identify your given leg lengths. So let me get some color coding going on here. Our leg lengths are, we have 3 and we have 4. Next step is put them into the Pythagorean theorem, which is leg squared plus leg squared equals hypotenuse squared. In this case, that means I'm doing 3 squared, so 3 to the power of 2, plus 4 to the power of 2. And that is supposed to equal, in this case, they called it x for the hypotenuse. So we'll say it should equal x to the power of 2. Now that we've made that formula, let's actually solve. And you always solve in the same ways. You first square both of your legs and then add them together. Remember, to square something means you're timesing it by itself. So you're really doing 3 times 3, which would be 9. And you are adding that to 4 times 4, or what is 16. And again, so we need to add those together. So if we do 9 plus 16, I should get 25, I believe. I'll double check. Yep, 25. We're not done yet, though. That's not the hypotenuse. That is 25 is x to the power 2. We want just x. So this is x to the power 2. Then, like we did in a previous lesson, our last step is to find the root of both sides. Remember, the root is just asking what number times itself gives you this number. And if I'm thinking 5 times 5 gives you 25. So that means x is 5 then. And that's the steps you do to find the hypotenuse when you're given the other two legs. Let's do it in another example. This time, we have 12 and we have 5. So, that means we're putting it into the formula. We have 12 to the power 2, or 12 squared, and that's going to be added to 5 to the power of 2, or 5 squared. And that should equal, again, they use x, so x to the power of 2. Just like last time, these steps really don't change. You're going to first do the numbers squared, or times themselves. So you have 12 times 12, which is 144. And they have 5 times 5, which is 25. So we have 5 times 5, which is 25. And this, in the end, is supposed to give us what x to the power of 2 is. Our next step is to add them together. So you have 144 plus 25, which gives us 169. Again, that's not the final answer, though. We need to actually now find the root of both sides. So on this side, this is where you might want to use a calculator. You could try to guess. For instance, I know 10 times 10 is 100, so I need a number bigger than 10, or I could use my root on my calculator. If I put that in the calculator, I end up getting 13. So 13 times 13 gives me 169. That means that 13 is my final answer. X is 13, or 13 is x. With that, pause if you need to get your notes in. But I'm going to move on to the U-try, where you'll be doing these same steps with some different numbers, though. Let me clear this up. And it is U-try time. Give it a hand to try to find the hypotenuse on your own for these two problems. All right, doing a check-in. Again, I'll keep things color-coded. If you first had 8 to the power of 2 plus 6 to the power of 2, and that was supposed to give you x to the power of 2, you would have been absolutely right so far. Do take note, our commutative property of addition means if you put the 6 first and then the 8, you'd get the same answer. It wouldn't matter. If you then knew that 8 times 8 is 64, and 6 times 6 is 36, you were doing great so far. Next, if you combined your numbers, which is 64 plus 36, it would give you 100. So if you got 100 is x to the power of 2, you were doing wonderfully. Lastly, if you remembered that that's not the final answer, you need to find the root of both sides, or what number times itself gives you 100. Well, 10 times 10 gives you 100. So that means 10 is the final answer. X is 10. If you got that x was 10, your hypotenuse, then you did it absolutely correctly. Now let's check the other problem. For this one, you have 11. So if you put 11 to the power of 2, plus you had 60. So if you put 60 to the power of 2, and all of this is supposed to equal x to the power of 2, then you set up your equation correctly. From here, if you did 11 times 11 and you got 121, plus you had 60 times 60, which should be 3,600. If you had that, you did your powers correctly. Next, your addition. So if you add 121 to 3,600, you should get 3,721. So if you got 3,721 equals x power 2, you would have been right. Lastly, you definitely would have wanted to use a calculator for this one. If in the calculator you put the square root of 3,721, you should have gotten 61. If you got that x was 61 for question B, you did it correctly and found your hypotenuse. If you need a pause to make any corrections, do so now. But I'm going to clear up and go to our closing, which is that we can use the Pythagorean theorem to find the hypotenuse of right triangles. It seems very fanciful, but in the end, you're just taking the two numbers you're given, squaring them, adding them together, and then finding out what is the root of that problem. That'll give you the hypotenuse. With that, we'll be working more with Pythagorean theorem in future lessons, but goodbye for now.